Two moles of an ideal gas are cooled isochorically and then expanded isovarically to lower the gas temperature back to the initial value. Find the entropy increment of the gas in this process. The gas pressure changed N equals to 3.3 times. The situation of the problem can be drawn on the PV diagram. When it is cooled, the pressure decreases, and after expansion of gas at constant pressure, volume will increase. During process 1 to 2 isochorically, the work transfer dW equals to PdV equals to 0. The internal energy change D equals to nu Cv dt for new mole. From first law of thermodynamics, dq equals to d plus dw equals to nu Cv dt. Hence, delta S1 equals to integration dq by t equals to nu Cv log T2 by T1 equals to nu R by gamma minus 1 log T2 by T1, equation 1. Now, during the process 1 to 2, P1 V1 by T1 equals to P2 V2 by T2. This implies T2 by T1 equals to P2 by P1 equals to 1 by N, as V1 equals to V2. Equation 2. Now for process 2 to 3, dW equals to P2 into under bracket V2 minus V1 equals to RT2 minus RT1 equals to nu R dt. Hence d equals to Cv nu Cv dt. Hence dq equals to d plus dw equals to nu Cp dt. And delta S2 equals to nu Cp log T1 by T2. Hence net entropy change del S equals to del S1 plus del S2 equals to nu into under bracket Cp into log n plus Cv into log 1 by n equals to nu into under bracket Cv plus R into log n minus Cv log n equals to nu R into log n. Putting all values, we get delta S equals to 20 joule per Kelvin. Answer. Helium of mass m equals to 1.7 gram is expanded adiabatically n equals to 3.0 times and then compressed isovarically down to the initial volume. Find the entropy increment of the gas in this process. The process can be seen on the PV diagram. First process 1 to 2 indicate the adiabatic expansion in which dq equals to 0, hence there is no increment in entropy. Process 2 to 3 indicates the isobaric compression. Then dW equals to integration PdV equals to P2 into under bracket V3 minus V2 equals to nu R into T3 minus T2 equals to nu R dt, and d equals to nu Cv dt. From the first law of thermodynamics, dq equals to du plus dw equals to nu Cv dt plus nu R dt equals to nu Cp dt. Hence, entropy increment delta S equals to integration of dq by t equals to nu Cp into integration dt by t to the limit t2 to t3. Hence, this implies delta S equals to nu Cp log T3 by T2. Now, V2 by V1 equals to N equals to 3 given. Question 1. During process 2 to 3, P2 V2 by T2 equals to P3 V3 by T3. Since P2 equals to P3, hence T3 by T2 equals to V3 by V2 equals to 1 by N, as V1 equals to V3. Hence, from equation 1, delta X equals to nu gamma R by gamma minus 1 log 1 by N equals to minus of nu gamma R by gamma minus 1 log N. putting nu equals to m by m equals to 1.4 by 4, gamma equals to 1.61, r equals to 8.31 joule per Kelvin for Kelvin, and n equals to 3. Delta S equals to 10 to the power minus 10. Delta x equals to minus 10 joule per Kelvin.